So in the prep, I asked you to look up the idea of a CD, a certificate of a deposit. And it's a pretty simple investment. It's kind of like a savings account, except they say you got to leave your money in there for a certain amount of time or we're not going to pay you. And you can put any amount of money you want in there. So my college fund for my daughter is like a certificate of deposit. I say, I'm going to put some money in there, and they say, okay, you got to leave it in for a certain amount of time, and then we'll give you interest on that. Now, often what happens is every year, say, they reevaluate your account and they put that interest back in your account. So maybe I have $1,000 in there and there is a 2% interest. And so at the end of a year, they're going to give me 20 more bucks. So now I have $1,020. But then the next year I have $1,020 that gets interest. So we're going to look at accumulating interest with these certificates. Now, sometimes with these, they only check your interest every year, but sometimes they'll do it monthly or maybe 4 times a year, quarterly. They could even do it daily. That's a possibility. Like every day, they up the amount of money in your account by some percentage. So we're going to explore that idea here. All right, so what we need to check out, and this is based on some stuff we did last time, that whole interest amount, which is a principal times an interest rate. The future amount, A, which is the amount we started with plus that extra interest. And cleaning that up, we get that A equals P plus PR. Notice we left the T off here for now. We'll put that back in a little bit. So in this scenario, we have $1,000 to start with. We're going to do it for a 5-year term that pays 2%. And 2% is what's called the annual percentage rate, APR. So if a percent is given as an annual rate, then you ought to measure time in years. If you have a percent as a monthly rate, then you would measure time in months. We'll do that after this one. So we want to know how much money you'll have in your account after the first year, round to the nearest cent necessary. Moving down, so we'll do that in a moment. How much will you have at the end of a 5-year term? So we're going to continue that 1 year to 2 years to 3 years to 4 years to 5 years. And down here, there's a summary of how those calculations work. So what I'm going to do is I'm going to go over this summary here. And that's going to answer questions 1, 2, 3, and 4, and 5. And then we'll move on to question 6 after that. So what's the relevant stuff we need to know now? A equals P plus PR, that's important. And then what is our P, what is our R, and how many years are we going to make this happen? Let's do it. Highly recommend you write this down. We're going to do this with a spreadsheet too. So again, this is lesson 4.1. It's called Compounding Makes Sense. Kind of a joke there. And what do we know? We know that A, our future amount, is equal to our starting amount, P, plus P times the rate. Now this formula right here is just for one time period, which for us at the moment, we're going to measure time in years. And we're just going to repeat this calculation each year. Now, remember from the last section, we know we can factor something like this. So another way to write that formula would be A equals P times, if we factor the P out, we get a 1 plus R in there. So we have a couple ways to think about this formula. The second one is the better way to think about it. Big star in your notebook on that one right there. So let's see, what do we know? We know that P, we are starting with $1,000. For R, that's our annual percentage rate, is given at 2%. So applying this formula right here, I have $1,000, and we're going to use the better formula right here, the factored version, times 1 plus 2%, and that's got to be a decimal. 2 divided by 100 is 0.02. Now, often in math, we like to simplify stuff, at least I do. Sometimes you guys do, right? This 1 plus 0.02, I can write that more simply as just 1.02. So I'm going to say my new amount here is 1,000 times 1.02. And I'm going to whip out my calculator, figure out what that is. You might look at that and say, oh, I can just shift the decimal point 3 places. Yep, that is true. Let's see, don't need that anymore. Don't need that anymore. 1,000 times 1.02 gives me $1,020. Right, so this would be after 1 year. Now I want to keep doing this. I want to see what happens after 2 years. Well, bottom line is every time I do this, I'm just going to keep applying this formula again and again and again. But at the beginning of every year, I get a new P. Okay, so let's look at year 2. What's happening in year 2? Well, in year 2, instead of starting the year with 1,000, I'm starting the year with $1,020. And I need to multiply by this same 1 plus R. And I already know 1 plus R is 1.02. So I multiply by 1.02, and that's going to tell me how much I have after 2 years. Calculator. So last one. And again, one cool thing about these calculators, they have a previous answer button, so I don't have to worry about mistyping something. Times 1.02. And it says $1,040.40. Right, so the first year I gained 20 bucks. The next year I gained another 20 bucks and an extra 40 cents, right? My interest got interest too. And this is what's called compound interest when we get to accumulate our interest. All right, let's keep going. We're on a roll. What should we do next? Well, how about year 3? In year 3, I'm starting off with that $1,040.40. And what's the bank going to do? They're going to say, hey, you get 2% added on, which means multiply by 1.02. Let's see what we got. Calculator, please. And notice how this is getting pretty repetitive. So this is a good place for a spreadsheet because a spreadsheet knows how to take the previous answer and do something to it. So previous answer times 1.02. And okay, so here I'm going to have to round a little bit because they're not going to give me 0.8 of a cent. So we're going to have to call it 1,061.21. What happens to those fractions of a cent anyway? Who keeps those? Apparently not me. All right, so $1,061.21 at the end of 3 years. I'm just going to say after 3 years again. All right, so this is once we have this factored form, it's pretty straightforward. What are we doing each time? Well, every time we did this, we took whatever month we started with and we multiplied by 1.02. Then we multiplied by 1.02 again. Then we're multiplying by 1.02 again. So in the 3rd year, I multiplied by 1.02 1, 2, 3 times. Pause and think. Repeated multiplication. What is repeated multiplication? Repeated multiplication is an exponent. So here's another way I could write each of these. The first time I did it, I started with $1,000. Switch color. And I multiplied by 1.02 one time. Now, if we backtrack, where did that 1,020 came from? Well, it came from the 1,000 times the 1.02, but then I multiplied by another 1.02. So my claim is that for the 2nd year, this is the calculation right there. I'm going to highlight that. Let's get my yellow highlighter. Starting with 1,000, multiply by 1.02, and then multiply by 1.02 again. So here I'm multiplying by 1.02 twice, which means I should have a 2nd power. So I claim this one right here is going to be 1,000 times 1.02 to the 2nd power. In the 2nd year, guess what's going to happen in the 3rd year? Right, that's going to be 1,000 times 1.02 to the 3rd power. And now I'm going to make a table out of this because I see a pattern heading down on this right side here. The year is the power, starting with the original amount. And we're going to test this on a calculator to make sure it actually works. But first, I want to put in a table. So if I look at the year versus this is called compound interest, where instead of the interest being a payout, like simple interest, the interest stays in your account and collects its own interest. So after 1 year, I get 1,000 times 1.02 to the first. After 2 years, I claim it's 1,000 times 1.02 to the second. After 3 years, 1,000 times 1.02 to the third power. That's what I had written down there, but I'm just putting it in a table because my notes were getting a little messy. Kind of focus for a second. Let's test to see if that actually matches what my calculator did earlier. So here's my third multiplication of 1.02. So I'm saying another way to get there is take the original starting point, $1,000, multiply by 1.02, raised to the power 3. Same number. It worked. So I don't have to start in year 1 and keep going. If somebody says, well, I don't care what's happening in year 2, 3, and 4. Can you just tell me what the heck's happening in year 5? Well, yeah, I'm just going to take 1,000, the starting point, multiply by 1.02, raise it to the power 5, and that's got to be what the account's going to be worth in 5 years, where the interest collects interest. Right, that's different than just straight simple interest where they ignore any interest in between. They just look what's going to happen at the end of 5 years in a slightly different way. So that's a whole different idea. We'll look at that later. I got a formula here. All right, so did we find out how much money would be in the account after the first year? Yep, we got it. Do we have the second year amount? Yep. Third year amount? Yep. I skipped 4, but I think you guys can do that based on what we just did, and we got 5. Now here, they're asking me a question. They want me to just rewrite this with exponents, but not do the calculation. So that would be back here in my notes. That's what I did on this line right here. Right, look back a page. That's where I took that 1,000 times 1.02 and multiplied by 1.02 again. When we put that together, we get 1,000 times 1.02 to the second power, and that's what that question's asking about. All right, let's read it again to be sure. So here, they're doing that same math I just did, written with some text where I was speaking that text. Take the expression 1,000 times 1.02 times 1.02. Remember that rule we have for multiplying powers? If the base is the same, you add the powers. And you might say there's no powers there, but yeah, there is. If something doesn't have a power, we can always say it's the power of 1. So I'm going to write that idea in a slightly different way. So another way to think about that is, let's put a new page in between. There was a rule that said if you had x to like the third plus, x to the fourth, you add the powers and get x to the 7th. If you have x times x, we know that's x squared. And that rule above works because this is really x to the first times x to the first. 1 plus 1 is 2. So here my x is 1.02 times 1.02, which is going to be 1.02 to the second. And we just happen to have that 1,000 hanging out front. All right, so I'm going to give you a minute to catch up, type in those numbers in. If you have a question, pop into the chat or voice something over to me, and then we'll move on to the next 2 parts. So we've got our formula, 1,000, our starting amount, times 1 plus our rate, raised to the power however many years go by, because t is years here. And then again, with that, we can just use it to plug in 10, give me a number, 20, give me a number, 40, give me a number, 70, give me a number, and 100. Now, I'm just going to show you how to do this on a spreadsheet. It's pretty straightforward there. bring up my Google Drive, new spreadsheet. Usually I like to name my sheets, lesson 4.1. And what I need to keep track of here are the years and the future amount. And years, we had 1, 2, 3, 4, 5, and then we were asked about 10, 20, and so on. And to do a calculation on the spreadsheet, the only difference than in a calculator really is you have the equal sign to start with. And then you would just type your calculation kind of like you would put it in a regular calculator. So in my regular calculator, I would write 1,000, and then I would use, but here we use an asterisk for times, right? We've done that before. And in this case, I have my 1.02. To get a power, that's where I use the Shift 6 I mentioned before. And the computer says the next thing coming is a power, it knows that. And instead of typing the power, I'm just gonna go click where the power lives. Like the first power lives in cell A2 on my computer. And so I hit enter, and it's gonna make that calculation. Now, Excel doesn't do this, but Google says, hey, you want me to keep filling that? I'm gonna say no, because I want to explain what the autofill means. That would work here. I just want to repeat that again. To enter a formula like this, we type equals, and then we just start typing the formula. Multiplication is the asterisk, Shift 8. 1.02 is my base. Power is Shift 6 to get that caret, that little hat key. And then instead of typing the power, I just click where the power lives, right? Mine lives in A3. And since I'm saying this number depends on that number, I can just fill this down and it's always going to think that. So when I fill it down, say to row 20 there, then this number right here, notice, is using the net number to the left to get the power. So there was a 20 there, it's throwing in a 20. One cool thing here is once I have that formula set up that way, and someone says, no, I didn't want to know 20, I wanted to know 50. I just type a 50 and hit enter, and it's going to recalculate that amount. Other thing, the spreadsheet will automatically round for me if I just highlight my numbers and tell it how to round. And I want to see, I could either do currency, or I could just say change the number of decimals I see. So if I do that a few times, I can say just show me 2 decimal places so it looks like dollars and cents. Instead of using the change the number of decimals viewed, I could have just hit the currency format, which does that, plus put the cute little dollar sign in front and commas, which is kind of nice. And again, if I replace that 50 with a 70, it's going to automatically update that amount for me. Remember, there's that almost $4,000 we found before. If I could leave this in there for 100 years, I would have over $7,000, starting with the original 1,000. And sometimes I put that in my formula too. So I'm going to just go up here to the top. I'm going to insert a row above and put a year 0, which is right before I start investing. And there's 2 ways I can do it. I could just type 1,000 because that's what I'm starting with, but the formula will still work right on that. So I could go equals 1,000 times 1.02 raised to the power and click on that 0. What do you think is going to happen? 1.02 to the power 0. Well, anything to the power 0 is 1. 1 times 1,000 should be 1,000. That should work. So now I have a spreadsheet that'll calculate any number I want. It'll show me as many as I want as long as I keep typing in years, and I could keep filling this down if I wanted more. Maybe I want to know 20, and I want to know 30, and I want to know 50, and I want to know 70, and I want to know 100, so on. All right, pause, let you all catch up.